and আজকে হচ্ছে we will work with the particle accelerator part. So এই particle accelerator যেটা ওইটা দেখবো, but আগে এটা আরেকবার recap করি. I would want to finish this topic by today, majority of it. So let's try. Right. So what is this thing? So যেটা আজকে দেখতেছি is called PET scan or positron emission tomography as the process name. Now, to understand what happens in this device, you first have to understand the principle of annihilation. So things collide and they annihilate each other. We need to understand that concept first. So এই জিনিসটা দেখতে হবে আমাদের. So what is annihilation? So the idea is that when you have a particle and an antiparticle. So if you're wondering what's an antiparticle, antiparticle is something that we have seen in our AS with the particle physics chapter. So you have a particle and antiparticle, and as the particle comes in contact with the antiparticle, they basically nullify each other, destroy each other. So they can't coexist. So what happens is all the energy gets converted to mass, or the other way around, sorry, all the mass gets converted to energy. So how do you convert mass to energy? So the formula is something we have been seeing multiple times in our A levels. It's E equals to mc square, right? So the amount of energy that's released, del E, equals to del mc square. So from there you can find out the amount of energy released in this process. But here's the catch though. During annihilation, what happens is this is a particle, right? And the particle that we are using in this particular example is an electron, and the electron interacts with a positively charged electron. So this is just called an electron, as you already know. The positively charged electron is called the positron. So it's called the positron. It's a positively charged electron, right? So these two particles, what they do is they come in contact. And the moment they come in contact, these two particles basically destroy each other. But according to the law of conservation of mass energy, right, you can't just disappear from the universe. You have to have some kind of balance and conservation law to be followed. So what happens is all the energy that you see here is coming from the mass that's out there. So all this mass that you see here just disappears and it turns itself into energy. But the question is, what type of energy? Because normally বলে আসি just energy বের হচ্ছে, right? So mass gets converted to energy. But the thing is, in this particular scenario, what actually happens is that there are two photons released, one photon and another photon, photons of gamma radiation. And the photons, they move off in opposite direction. This is a very important feature you have to remember, okay, that they go in opposite direction. The device uses this idea that they go off in opposite direction. And these are photons released here. And once we do the energy calculation, they turn out to be photons of gamma radiation. So these are gamma radiation photons that are coming out from here. So yeah, that's what's happening here. So last class, what we did was we found, like, mathematically what the frequency was, and this is what we did. So how do you do your math? First, you find the total mass available. তারপর এই massটাকে এনার্জিতে কনভার্ট করো ইউজিং E equals to mc square. তারপর যেহেতু সিঙ্গেল ফোটনের জন্য দরকার, ওই এনার্জিটা দুইটার মধ্যে স্প্লিট হয়ে যাবে। So I divide by 2 to get the energy of one photon. Then I use the formula E equals to hf to find the frequency of one single photon. And the frequency ranges in the range of gamma radiation. So this is what annihilation is. Now, the question is, how is this related to our chapter? When I'm the chapter can be related. So I'll just give you like a little bit of heads up. Can we the darker? So apparently the process that we're going to look for works like this. It's a summarized version. I'm not details are to point. So this is your body and your body structure, whatever the structure that you're trying to investigate. Let's say it's a cancerous tumor or something, just saying, right? And this particular part of the body has electrons every single place. So imagine the whole thing is just filled with electrons out there. So you can have plenty of electrons in this structure. So there's like electrons everywhere, right? So J particle red shade code to see these are all electron filled structures out there. Now, what happens is we inject something into the body. It's called a radio tracer. And this radioactive tracing element, right, goes into the body. It goes to different parts of the body. It's a liquid, right? And it goes into wherever you want to investigate. So that we cannot inject kora hoy. And as it goes to those parts of the body, this radioactive element that we are using here, usually fluorine 19 is the one. And fluorine 19. This one undergoes a decay that is known as a beta plus decay. And if you have some memory of your AS, you'll remember beta plus decay is essentially a decay that takes place when what is released from your structure, a positron. So the thing that you're seeing here is a radioactive element is now releasing millions and millions of positrons into your body. So what happens is a body এই জায়গাগুলোতে positron বের হচ্ছে, and the positrons are beamed into the body. And as the positrons are beamed into the body, the positrons here interact with the electrons that are already here. মানে তোমার বডির যে ইলেকট্রনগুলো আছে ওগুলোর সাথে interact করে. So this is all positron out there. These positrons interact with the electrons in your body. Can you tell me what happens after that? Is it these are electrons here already in your body, the red dots, and the green dots are positron that are released by the radioactive chemical that we're using here. What will these do to each other? What I'm trying to show. So basically, that radioactive element is going through your body, the fluorine 19, and it's releasing positrons as it goes through your body. And the positrons are now interacting with the what in your body, the electrons in your body, right? As they interact with the electrons in your body, what is released in the process? Annihilation takes place, right? Yes, exactly. There are gamma radiations coming out from your body, like this and like that. Every single annihilation interaction is producing gamma radiation out there. So এরকম করে gamma radiation বের হচ্ছে, এরকম করে gamma radiation বের হচ্ছে, but the interesting part is gamma radiation photons come in pairs. Do you understand what I mean by that? মানে প্রত্যেকটা gamma photon comes in twos. একটা লেফটে যায়, একটা রাইটে যায়, একটা টপে যায়, একটা বটমে যায়, একটা ফরওয়ার্ড যায়, একটা ব্যাকওয়ার্ড যায়. Why is this important? Let's see the bigger picture. This is the tumor that we are talking about, right? Around this whole thing, there's a sensor, a very sensitive, sophisticated sensor out there. This sensor picks up the gamma photons that are coming in. So এখানে gamma photonটা গিয়ে এখানে বাড়ি খেলো, it picks up the gamma photon that came here. But ওর একটা counterpart ছিল তো, right? There was another gamma photon out there. Where does that gamma photon go? That gamma photon goes to the other side. And the sensor can pair up every gamma photon out there. কেমনে? Because all the gamma photons that are released in this process typically have unique frequencies because the energy they carry is different. So the photon frequency that's generated is also different. So as these gamma photons are beamed everywhere like that, the sensor can actually recalculate, reverse the gamma photon traveling here and there and find out where did it come from. So এটা যেটা করে is, let's say, I'll give you a simple example. Let's say this one is 1 into 10 to the power 15 hertz. And the other one must be also 1 into 10 to the power 15 hertz, but because equal frequency te ber hocche. This one goes and hits the target here. This one goes and hits the target here. The computer knows that this must be from the same place, but এটা marginally longer time নিচ্ছে to reach, right? মানে ধরো যে এটা এখানে এসে বাড়ি খেতে যে টাইম নিল, এটা আর একটু extra time নিচ্ছে. The computer can then pinpoint the exact location from where that radiation came, and it can then map an internal structure of whatever you're trying to figure out. So what it does is basically look into places inside the organ and pinpoint the location from where the radiation came, and then that can be used to generate a picture. I'll show you a picture. The picture is little interesting. ওই পিকচারটা কিরকম দেখতে হয়? It's not like a X-ray or a CT scan. It's a little different. But yeah, basically the PET scan produces a much more detailed internal structure. How internal? Anything inside your body that can produce an electron or contains an electron will show up here. So it basically shows everything inside your body. It goes down to cellular level. And that's what we need for, let's say, diagnosis of cancer growth or cells that have been degenerated or they're multiplying at a rapid rate. A cellular level যদি আমরা distinguish করতে চাই, we need this thing called the PET scan. So this is called the positron emission tomography. So we emit positron inside the body. The positrons react with the electrons inside the body, and there's like continuous gamma radiation coming out from every side. Those gamma photons are detected, and as a consequence, you have like a picture generated. Couple of questions that come to students right away. আমি ওগুলা address করে দেই. isn't gamma radiation more harmful than X-rays? Yes, that's actually true. But these are highly energetic gamma photons that then just pass through your body. They're not absorbed. And I think you know by now, absorption is actually the problem, not the radiation itself. If the radiation gets absorbed by your body, that's an issue, right? These don't usually get absorbed by the body. Also, these are photons. These are not like a continuous gamma radiation source. They're like just, small amounts of photons that are released. Individual particles of gamma, it's not very intense to cause harm. Okay. So yeah, that's the main concept. So আমরা annihilation কেন করি? To generate gamma radiation. And not just gamma radiation, because you can generate gamma radiation from rocks and minerals as well, right? This is gamma radiation from the inside of the body, and it's two photons that come out, pair photons, and these pair photons are of the same energy, so or frequency, so you can actually predict where they came from. So it can 3D map the location of things inside your body. And that's why the annihilation part is arguably the most important part here. So, তোমাদের question থাকলে আমাকে বলো. Ask me questions that you have regarding this. আমরা এখন next যেটা করবো is I'm going to teach you how to create this fluorine 19. এই fluorine 19 টা কেমনে generate করতে হয়, it's a very important process. ওইটা is another part of the topic, but that doesn't have anything to do with the diagnosis part. So diagnosis টা cover হয়ে গেছে. I want you to ask me any questions you have regarding the diagnostic process. I will try to show you some animations about the thing, but আগে তোমাদের কোয়েশ্চেনগুলো আমি শুনে নিই, তাহলে আমার একটু easier হবে to explain what problems you have in particular. Does the whole body emit gamma radiation? Well, depends. So it depends where are you injecting this tracer, a fluorine 19 টা তুমি যেখানে ইনজেক্ট করবে ওইখান থেকে খালি বের হবে. So it's not like it's going to go all over your body. It's just locally injected into the location that you're going to investigate. Question থাকলে আমাকে বলো. Okay, now I will teach you how to generate the fluorine compound that we have. Okay. Right, so let's go to step 2. So তোমাদেরকে হচ্ছে আগে এটা দেখে like a map of what's happening here. So how does a PET scan work? This is a summary, okay? এটা হচ্ছে step by step আমাদের জানতে হবে. So আমি step 1 থেকে start করি. So the whole process of PET scan. Okay, let's see how PET scan works. So PET scan. So PET scan, the first stage of your PET scan process happens way before the patient arrives at the diagnostic center. So আগে থেকে বলে রাখতে হয়. The first thing that has to be done here is that you need to use a particle accelerator. So a particle accelerator use করা হয় to generate radioactive tracer. এটা কি একটু এক্সপ্লেইন করতেছি in a minute. Number 2 step হচ্ছে you need to create tracer that is absorbed by the body. So you have to create something that's taken in by your body. Number 3 হচ্ছে it is injected into the body. Number 4 and number 5 হচ্ছে তোমাদের একটু আগে বুঝালাম. So number 4 হচ্ছে you have Ni and gamma emission. And lastly হচ্ছে detection. So these are the steps. So far কোনো রকম question আসেনি, so I can't really say ওরা কি জিজ্ঞেস করবে পুরোটা নাকি partially নাকি ভেঙে. যে question গুলো করছে they were more targeted towards the math that we did the other day. Okay, so just এটা আগে থেকে বলে রাখলাম. That's the reason why I am going to show you the whole thing. Okay, like A to Z just এখানে সব বুঝাবো তোমাদেরকে. Right, so let's start with the particle accelerator. So particle accelerator টা কি করে and why do we need it? It's part of the requirement. Requirement কোথায় আমি তোমাদেরকে দেখাই. It will say that এখানে হচ্ছে radio tracer tracer. তোমাদের টেক্সট বুকে দেওয়া আছে, এখানে বেশি মেনশন করে না. এখানে আন্ডারস্ট্যান্ড ট্রেসার, this is the tracer here and tracer. Okay, let me explain how to create the tracer. A tracer creation is a problem. Okay, so let's see how to generate tracer. So if you want to create a radioactive tracer, কেমনে কাজ করে? So radioactive tracer. So these are not naturally found out there. We need to have a radioactive element that produces beta plus or positron. So এটা করার জন্য we need like a particle accelerator. So what's a particle accelerator to explain for you? So essentially you have this circular disc-like structure, and a structure is placed within a magnetic field, like a really strong magnetic field. And once you place your particle in this magnetic field, like very strong magnetic field, what happens is the particle will start to undergo acceleration. I'll show you how. You have this in your circular motion chapter, magnetism chapter, দুটো মিলে যে চ্যাপ্টারটা particles in the magnetic field ওইখানে. So আমি আগে draw করে নিই তাহলে easier হবে. So you have this structure here called a particle accelerator. খুবই sophisticated একটা device, মানে it's something that you find in the most advanced physics labs out there. But আমাদের এটা দরকার. কেন এটা দরকার আমি বুঝাচ্ছি in a minute. So আমাদের এটা দরকার hospital-এ. Okay, I'll explain in a minute why. So you have this thing called a particle accelerator. এটা কেমনে কাজ করে একটু বলি. এটার ভিতরে you release like an electron or a proton, anything that's charged. And these structures that you see here, they have magnetic field going through them. So there's a magnetic field passing through this place here. ধরো উপরে হচ্ছে north, right? So that's the north at the top and the south at the bottom. So this is north and south. So because of this magnetic field that you see here with the north and the south here, what happens is your particle undergoes circular motion. Why does your particle undergo circular motion? We have seen this in the particle physics chapter. There is actually a magnetic force generated on your particle, and this magnetic force is perpendicular to the direction of your particle. অ্যান্ড এখানে হচ্ছে একটা হাই ভোল্টেজ দেওয়া থাকে। আমি একটা জিনিস জাস্ট বলে রাখি, এই ফুল ডিটেলটা তোমাদের অ্যাকচুয়ালি লাগে না, ওরা বলে দিচ্ছে সিলেবাসে দ্যাট ইউ ডোন্ট নিড দ্য ডিটেল, বাট আই জাস্ট ওয়ান্ট টু শো ইউ সাম ব্রিফ আইডিয়া অ্যাবাউট দিস। এখানে যেটা হয়, দ্য পার্টিকল এক্সপিরিয়েন্সেস সেন্ট্রিপিটাল ফোর্স which is provided by the magnetic force. The centripetal force is m v square by r. Magnetic force হচ্ছে m bqv, and এখানে v টা cancel out হয়ে যায়, so you get r equals to bq divided by, sorry, উল্টা, r equals to mv divided by bq. And if you remember, this was a very important equation we have. And because of this, what your particle does, let's get to the important part, is your particle starts to spiral inside. খুব হাই ভেলোসিটি গোলে ঘুরতে থাকে এই জায়গাটার ভিতরে, ওকে? ইটস স্পাইরাল ইনসাইড at very high rates. As it keeps spiraling at very high rates, at one point what happens is that it goes and hits a target of fluorine, and ওই টার্গেটের সাথে বাড়ি খেয়ে it creates this radioactive fluorine out there, which is fluorine 18. And this fluorine 18 is radioactive, and it decays by releasing positrons, so beta plus particle. So এটা ন্যাচারালি পাওয়া যায় না, এটা আমাদেরকে বানাতে হয়। And a fluorine 18 production জন্য you need this thing. It's called a particle accelerator. Now you might be wondering that you not take, why are we talking about this? I'll explain in a minute. So this is an accelerator. So let's understand why is this important for us. So number one, fluorine 18 has a very short half-life. Etar half-life হচ্ছে around 6 hours এর মতো. Okay, so you have 6 hours now short. Etar half-life হচ্ছে 2 hours. So fluorine 18 has a half-life of 2 hours. 2 hours মানে হচ্ছে এটা t half. That 2 hours এর মধ্যে the activity becomes half. মানে it's dying out. Now let's say you want to undergo this diagnosis, right? You go to the hospital. হসপিটালে তোমার বডির ভিতরে ফ্লোরিন 18 টা ইনজেক্ট করবে। এটার হাফ লাইফ হচ্ছে 2 আওয়ার্স, খুবই ভালো। তোমার শরীরের ভিতরে যাবে, উইদিন আ ডে ইটস অল গন। কেন? 2 আওয়ার্স যদি হাফ লাইফ হয়, তাহলে 4 আওয়ার্সে হাফ হয়ে যাবে, তারপর 2 আওয়ার্সে হাফ হবে, 4 আওয়ার্সে 1/4, 1/8, 1/16, এরকম করতে 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 12 আওয়ার্স, 16 আওয়ার্স, 20 আওয়ার্স এর মধ্যে ইটস অল গন। So it's safe. It doesn't stay in your body for long enough, right? So that's one good advantage. But that comes with a problem. Problemটা হচ্ছে হসপিটালের পয়েন্ট অফ ভিউ থেকে চিন্তা করো। হসপিটালে কি ওরা বটলের ভিতরে হচ্ছে এই ফ্লোরিন 18 নিয়ে রেখে দেয়? ওরা ওরা রেখে দিল, দে হ্যাভ ফ্লোরিন 18 in a bottle like that, ওরা পেশেন্টের জন্য রেখে দিল। Can you tell me what's the problem with this, that having fluorine 18 stored out in a bottle for patients to show up later on? এই প্রসেসটা কেন হচ্ছে ভায়াবল না? Can you give me a reason that why is it not possible for you to store fluorine 18 in bottles and vials so that patient যখন আসবে পেশেন্টকে তুমি জাস্ট দিয়ে দিবা? এটা কেন পসিবল না? কেউ আমাকে এক্সপ্লেইন করতে পারবে the reason behind this? Why can't we do this? They will be over before the patient might show up. Absolutely, right? আমার যদি হচ্ছে হসপিটালে হচ্ছে আমি ফ্লোরিন 18 রাখি, কোন জায়গাতে পেলাম, দিনের শেষে ইটস অল গন বিকজ ইট অল ডিকেড। সো আমি প্রত্যেক দিন হচ্ছে কোথা থেকে নিয়ে আসবো? ইনফ্যাক্ট কোথা থেকে নিয়ে আসবো ইটস অলসো ফ্যাক্টর। লেটস হ্যাভ আ ফ্লোরিন 18 ফ্যাক্টরি বাংলাদেশে, ওকে, somewhere. By the time you pass through the traffic and you get to the hospital, right, দেখবা যে it's gone, because 6 hours ধরে লাগছে from the production facility to the hospital and to the patient, right? 6 hours এর মধ্যে it'll decay to 1/64th the original value. So your fluorine 18 is now, it's barely any activities left. That's the problem with this particular device. A PET scanner সবচেয়ে বড় চ্যালেঞ্জ হচ্ছে the radio tracer that you have has to be a very short half-life tracer. But very short half-life tracer মানে হচ্ছে you need to make this tracer at the hospital. Do you understand my point? And that's the reason why I had to teach you this accelerator, because তোমাদের one of the biggest drawback of PET scan হচ্ছে you need to create the tracer in the hospital. And তখন স্টুডেন্টরা বলে কেন? Because half life short তার জন্য। আচ্ছা তাহলে কেন প্রবলেম, এটা বানায় না কেন? Because this device is very complicated. That's why you can't have this in every hospital. This is a particle accelerator. It's like one of the most advanced devices physics has ever come up with. You need it to be in your hospital so that it can produce that fluorine 18 for you, so that you can go and give it to the patient immediately. And that's the reason why PET scans are super expensive. The whole facility is super expensive. On top of that, এটাকে maintain করা খুব difficult because you have to understand you're using the particle accelerator to create the tracer. Now you might be wondering, are there alternates out there? Unfortunately, there's something else called technetium, another radioactive element. ওইটার জন্য particle accelerator লাগে. So at the end of the day, beta plus decaying particles, right, can only be generated using a particle accelerator. So that's the reason why you need to have a particle accelerator in your hospital so that you can immediately provide the radioactive tracer to the patient. Okay, right. That's step number one, is it? The accelerator. তারপর হচ্ছে the tracer has to be absorbed by the body. So আমরা যেটা করি step 2 তে, এটা complicated না. So let's go to step 2. Step 2 তে we have generated the fluorine 18, right, which is radioactive. এটাকে আমরা mix করি with a solution. So we take our fluorine 18 and we combine this with fluorine 18, right? We combine this with glucose, sugar solution. Why? Because the body needs to absorb this. Fluorine 18 directly body absorb করতে পারে না. It's a bit of an issue for the body to take in so much fluorine. Probably just your teeth might take some amount of it as a layering, but generally body নিতে চায় না। তার জন্য আমরা এটাকে combine করি। So your fluorine 18 is added to glucose, sugar, right? And then it forms fluorodeoxyglucose. I think that's the word, fluorodeoxyglucose, right? So this, I don't think the word to jump away, but that's basically what's generated, okay? So this fluorodeoxyglucose is what the body absorbs. Can body takes this as glucose, so it goes into your tissues and muscles very easily. I want to inject this into my tissues and muscles, right? My tissue and muscle needs to take it in. If it's something that's not something worthy for my tissue and muscle to absorb, তাহলে ওটা হচ্ছে পুরো সব জায়গায় ঠিক মতন যাবে না। So I don't know if you know this, your blood vessels, muscles, tissues, everything feeds on glucose. It needs that sugar, right? So তখন হচ্ছে তুমি বডিতে যখন দিবা, it will absorb this very easily, and then it goes everywhere wherever you injected this. Okay, so first step হচ্ছে accelerator. Number 2 হচ্ছে to create the tracer with a binder. Tracer with binding agent. Binding agent মানে হচ্ছে glucose. And then what do we do? Then you inject this into the body. So step number 3. Step 3 is the injection. Injecting into the patient. এটা কোথায় ইনজেক্ট করা হয় পেশেন্টের মধ্যে? Wherever you want to do your diagnosis. Okay, so let's say where do you want to do a thyroid, right? So thyroid gland মধ্যে দিতে চাচ্ছ. So this is the person's neck, and what you do here is you will inject this into the thyroid gland here to see how the thyroid is responding to treatment. So এখানে দিবা, and the thyroid gland now has what inside it? The fluorine 18. And the thyroid gland that has the fluorine 18 inside it will interact with the electrons that are already present here. And from there, you will have what coming out from every side? You'll have your gamma radiation coming out from every side. So the gamma radiation they're all coming out in pairs. And this is done when you are inside like the diagnostic machine. So a machine ta shop detect korteche side theke. So it's detecting everything from the sides. Right. So a side je machine ta হচ্ছে সব radiation pick up করতেছে. And as it picks up all the radiation that comes here, it has to do something. যেটা হচ্ছে এটা I have seen in the textbook. I don't think syllabus কোনো জায়গায় mention করা আছে, but তাও শিখাই. There is a device called a photo multiplier. So photo multiplier টা যেটা করে basically intensity বাড়ায় দেয় of the gamma photon, so it can be detected more easily. So যে gamma photon গুলো এখানে আসতেছে এগুলোকে amplify করে. Photo multiplier কাজটা হচ্ছে to make the image more clear. So a gamma photon গুলোকে হচ্ছে amplify করে, because you have to understand খুবই কম energy থাকে gamma photon গুলোর, right? 10 to the power -16, -19 এরকম. The photo multiplier amplifies the energy received. And once that is done, comes our next stage. যেটা হচ্ছে the image generation. So image generation, and তখন হচ্ছে it produces the image that we normally see in your PET scan. So let me show you কি show করে PET scan. Okay, let me show you a picture of a PET scan. That That's how a PET scan looks like. Now you might be wondering, it looks nothing like a person or an X-ray or CT scan. It's not very clear, but to a doctor, this is actually very good. Can I believe? How does a doctor know what's going on here? And এটার জন্য হচ্ছে একটু basic biology দরকার, এটা আমাদের জিজ্ঞেস করবো না exam, but তোমাদেরকে একটু বুঝাই, okay? So let's say there's this part of your body যেটাতে হচ্ছে some kind of malfunction হচ্ছে, maybe tumor, benign tumor, or you have some kind of aggressive growth or something. এখন ওটা ডক্টর চেক করতে চায় যে এটা কি ক্লিয়ার আউট হয়েছে নাকি। তো ওরা যেটা করে, দে ইনজেক্ট দি ট্রেসার, তো বডির ভিতরে ট্রেসারটা পাঠালো, and the tracer now goes everywhere যেখানে তুমি চেক করতে যাচ্ছ, it goes everywhere like that. But the problem is that the tracer may not go everywhere equally, and the reason behind that is মাঝখানে, let's say you have some kind of growth here. Growth মানে হচ্ছে something that's not normal. So এরকম কিছু একটা. So once you put the tracer here, you'll find that যে এই মাঝখানে যে রিজনটা, এই রিজনটার ভিতরে the tracer did not go in properly. কেন? These cells are degenerative cells, মানে they're not working properly. So ওরা গ্লুকোজটাকে ঠিক মতো নিতে পারে না. So once you start to get gamma radiation coming out from this, right? কি নোটিস করবা? You'll notice that the gamma radiation that's coming out is coming out evenly from every side. বাট এই মাঝখানে যে জায়গাটা, এখান থেকে যে গ্যামা রেডিয়েশনটা বের হচ্ছে, এটা একটু ডিফারেন্ট ইন্টেন্সিটিতে বের হচ্ছে। কেন? নট অল অফ ইট ওয়াজ অ্যাবজর্ব প্রপারলি। এন্ড যখন ডক্টর এই যেটা দেখে এখানে, ওরা দেখতেছে ফর এক্সাম্পল হচ্ছে ট্রেসারটা দিছে এখানে, আই এম নট রিয়েলি শিওর কি ডায়াগনোসিস করতে চাচ্ছে এখানে, বাট জাস্ট টু গিভ এন এক্সাম্পল অফ দিস প্লেস হিয়ার, এখানে তুমি নোটিস করবে মাঝখানে যে জায়গাটা রেড, ওইটা খুবই বেশি ইন্টেন্স, তার মানে দেয়ার লট অফ গ্যামা রেডিয়েশন কামিং ফ্রম হিয়ার, রাইট? বাট পাশের জায়গাগুলো ধরো ইন্টেন্সিটি একটু কম, which can suggest to the doctor that the glucose was not absorbed properly. And why wouldn't it be absorbed properly? Because the cells there have some issues out there. And typically cancerous cells, right, are the ones that will not take in the glucose like the ones around it. Cancer cell ki hoy at the end of the day. Your cancer cells, right? They're basically your cells. Ar kichu na kintu. They're not anything different. It's just the fact that they have some issues in their structure. They're not well designed. They're not meant to do what they're doing right now. মানে they're not supposed to be here. So এই degenerative structures গুলো যেগুলো থাকে, cells গুলো different দেখতে থাকে। তোমার normal cells যেরকম দেখতে, cancer cells গুলো একটু different হয়। And because they're broken, they're shattered in some places, they have different structure, এরকম লম্বা হয়ে যাচ্ছে। Cell তো normally এরকম হয়, animal cells, right? মানে like that. But এখানে যেটা দেখবা যে they're like broken and stuff like that. So এখান থেকে যখন হচ্ছে তুমি রেডিয়েশনটা পাচ্ছ, you'll find that the radiation is not the same as from a healthy cell. এগুলো absorb করতে পারে না properly, and that gives a doctor an idea what's actually going on there, and that's what PET scans do. So this PET scanner main purpose হচ্ছে, the word they use is to test the metabolic activity of your cells. Okay, এই metabolic activity টা দেখার জন্য হচ্ছে PET scan use করা হয়. Anyways, this is the summary of the whole process. So আমি অ্যান্সার দিচ্ছি তোমাদেরকে, নোটস দিচ্ছি, সবই দিচ্ছি, বাট আগে একটু দেখো কোনো ক্লারিফিকেশন লাগে নাকি, বিকজ ইউর দি সেকেন্ড ব্যাচ হুজ ডুইং দিস। এখন পর্যন্ত কোনো কোয়েশ্চেন আসে নাই তো, সো পাস পেপার কোনো প্র্যাকটিসের কিছু নাই, লাইক নাথিং ভেরি কম্প্রিহেন্সিভ। সো আই ওয়ান্ট টু ক্লারিফাই ইউর কোয়েশ্চেন্স থ্রু ইউর কোয়েশ্চেন্স, মানে নট পাস পেপার কোয়েশ্চেন্স। তোমাদের কোয়েশ্চেন গুলো আগে বলো। মানে এটা ধরো একটা এখন 8 মার্ক কোয়েশ্চেন দিয়ে দিল, রাইট, যে পুরো পেট স্ক্যান এক্সপ্লেইন করো, তাহলে তো একটু ঝামেলা হতে পারে। আই উইল গিভ ইউ দি অ্যান্সার, বাট তোমাদের কিছু তো বুঝতে হবে। সো এটার জন্য আই উড প্রেফার যে তোমরা কোয়েশ্চেন করো আমাকে। Why did we use fluorine 18? Very good question. Fluorine 18 is a radioactive element and it undergoes beta plus decay. So fluorine 18, when it decays, it produces beta plus. The beta plus basically means your positron. And the positron then interacts with your electrons to produce a gamma radiation. So fluorine 18 is the best, element that we have for producing beta plus. Can you explain the first step again? First step as in the accelerator. The accelerator. Okay, so the accelerator, right. So fluorine 18 is not natural. If you look at normal fluorine, fluorine, by the way, is not a very, it's very reactive at the gas. Fluorine the gas to produce for it. So you probably learning chemistry. When it's reactivity series, it's in the group 7, right? Fluorine, bromine, iodine, chlorine, not really very good things to work with. So fluorine is generally kind of toxic. But ওটা যদি গ্লুকোজের সাথে অ্যাবজর্ব করে দেন the body can take it well. তার জন্য আমরা ফ্লোরিন টার্গেট করি। এখন ওটা ন্যাচারালি তো ফ্লোরিন 18 পাওয়া যাচ্ছে না। It's radioactive. So how do you create fluorine 18? So যেটা করা হয়, you take a target হচ্ছে either ফ্লোরিনের আগে বা পরে কোনো একটা এলিমেন্ট, মানে in the periodic table, and you take like a proton or an electron and you speed it up. Generally একটা proton নেওয়া হয়, and protonটা খুব হাই স্পিডে চলে যায়, very high velocity. And that very high velocity proton then goes and hits the target. When it hits the target, it sometimes knocks off particles from the target. And ওই target থেকে যখন knock off করে কিছু বের হয়ে যায়, the byproduct can be fluorine 18. So আমরা fluorine 18 টা generate করি by knocking off particles from some other element. And then you have this radioactive element generated. So এটা naturally যেহেতু form হয় না, এটা আমাদেরকে artificially বানাতে হয়। এটা বানানোর জন্য we need to have this device here called a particle accelerator. So এটা হচ্ছে is the reason of this thing. Now this is very sophisticated, expensive, difficult to handle, manage একটা device, which is the reason why PET scan হচ্ছে disadvantage জিজ্ঞেস করে। তো one of the disadvantage is the cost and the technical ability to be able to use one of these. Explain the metabolic activity. Yes, metabolic activity is essentially the fact that you have your cells here, all the cells in this location, right? They're typically all similar types of cells, and they're typically supposed to behave the same way. So they're supposed to absorb your glucose at the same time, all of them. So the glucose should go into the system simultaneously. But because there are some cells at the center which are not properly functioning, they will take the glucose in slowly. They will, react with the glucose differently. So when the glucose is taken in, right away gamma radiation is coming out, right? So these healthy cells are producing gamma radiation. So you can see them very easily right now. But you'll find that the center part hasn't taken in the glucose yet. That's how you'll notice that in your picture that the surrounding is very bright and the center is not bright, which means that the gamma radiation is coming out from the outside very easily, but the center is not taking in the gamma radiation. And because the center is not taking in the gamma radiation, it means that the cells there have some issues. And that typically means the cells are either degenerated or dead or cancerous. এটা হচ্ছে যদি ডক্টররা দেখে, they might do something called a biopsy, where they'll actually take the cells from there and look under a microscope. But তার আগেও তুমি এটা করতে পারো to see. What hospitals in Bangladesh actually has a PET scan? PET scan হচ্ছে, I know one hospital, আমি তাও একটু check করে দেখি. So this hospital Evercare, they have one. They have I think the only one. আমি তাও check করে দেখি. They're like government hospitals that have it, but uh, mm, yeah, there's one government hospital out there, and couple of hospitals, private hospitals that are. Yeah, there are like 4 or 5 of them, I think. Um, I thought cancers have greater metabolic activity in normal cells. That's actually true. The thing is, once you start taking chemotherapy, after and during the chemotherapy, they start to give you this PET scan. And by doing that, you can see if the cells have died or not. And they'll start to have less activity compared to the rest of the body. So as a initial diagnosis, they don't use PET scan because they have to do biopsy. They'll like take the cells from the cancerous location, see the cells, and they see that the cells are like going out of control, right? And what they'll do is they will then start doing like your chemotherapy or radiotherapy to treat the cancer, right? And then let's say a few months in, the doctors want to see if it's responding to the chemotherapy or not. So there are two ways they can do this. At touch, they can again do biopsy at that location and see how the cells are doing. The other one is they feed the cells in that location glucose and they see how the cells are reacting. If the whole thing gives you a uniform color, it means that the cells have gone. And if it gives you an extra bright color, it means those cells are highly active. And if it gives you a dark color, it means the cells are like dead. So the good thing would be to see a location where the cells are like this, that the center is not showing any activity, which means the cells are dead, which is fine. I mean, cancer cell dies, it's no one's loss. But যদি এটা extra activity show করে, that's a problem. It means the cells are multiplying more than they should. Okay, let's see if I can show you some animations on this. Let's start with PET scan. There are different models of PET scan as well. So I'm not really sure এখানে যেটা আছে ওটা কি তোমাদেরটা সাথে ম্যাচ করবে নাকি? But you'll get some idea. মানে overall science তো same. Okay, let's see. এটা আমি আবার তোমরা যখন হচ্ছে অফলাইনে আসবে আবার দেখাবো জিনিসটা, বাট এখন হচ্ছে আমি ডিসকাস করি। Right, so this is how PET scan works. Or a PET CT bole কেন? Because PET scan machines also have to do CT scan. I'll explain in a minute why. কারণ দুইটা লাগে একসাথে, খালি PET scan দিয়ে কাজ করে না। So এরকম দেখতে হয়, you are going to pass the patient inside like that. So device যদি চেক করো, there's this detection ring খুব তাড়াতাড়ি গোলের ভিতরে থাকে। এটা হচ্ছে এক্স-রে টিউব দেওয়া আছে because it's a CT scan machine as well. Usually দুইটা একসাথে করতে হয়. I'll explain in a minute কেন দুইটা একসাথে করে. And this is the fluorine molecule I'm talking about. Okay, so fluoro deoxyglucose. So এই যে fluorine যেটা green color দেখতেছো, that fluorine is the radioactive one. এটা যখনই একটা ইলেকট্রনের সাথে বাড়ি খায়, it produces your এটা জানি positron. And the way it works is এই যে ইনজেক্ট করলাম, ইনজেক্ট করার পরে ফ্লোরিন 18টা হাতের মধ্যে চলে গেছে, so we are diagnosing someone's hand or maybe the full body now, I think. আচ্ছা, পুরো বডিতেই যাচ্ছে। And then we're going to put the person inside. Right, so tumor কোথায়? টিউমারটা ওই জায়গাটায়, right? So as the molecules are going here, তোমরা কিছুক্ষণ দেখো কি হয়। So your body absorbs them, right? And electron আসুক কোনো জায়গা থেকে, it is a positron, and there are plenty of electrons nearby, and actually the body and 2 gamma photons came out, and the 2 gamma photons that come out are shot outside the body. So it's basically like a firework of gamma photons coming out, and as it goes inside the body, the gamma photons are detected by the machine, and with the right side layer by layer দেখাচ্ছে. So you can see the one part is red, right? The red part is essentially where the tumor is. It produces a different metabolic activity. So তারপর তুমি 3D তে পেশেন্টটাকে সরায় দেখতে পারবা, like what's going on. So I'll explain in a minute why CT scan is also needed, okay? কারণ PET scan হলেই তো হয়তো CT scan কেন দরকার, I'll show you soon. তোমরা কি বুঝছো এই বেসিক আইডিয়াটা? I mean the principle is the same, right? এখন কে কোথা থেকে ফ্লোরিন নিয়ে আসে, কেমনে নিয়ে আসে, that's the rest of the device. Okay, let's move on. Next হচ্ছে এই ইমেজিনের পার্টটা তোমাদের অত দরকার নাই, বাট ওই যে স্লাইসিংটা একটু দেখো। সো রাইট সাইডে দেখো এই যে লেয়ার বাই লেয়ার জেনারেট করতেছে। সো ওই লেয়ার গুলোকে একসাথে কম্পাইল করলে ইউ গেট দ্য 3D image on the left. So now the whole thing.
Medical imaging techniques make it possible to obtain visual information about the body's internal organs without surgical incisions. One of these techniques is positron emission tomography.
Can you guys hear the audio? Video যে অডিওটা শোনা যায়? আচ্ছা, ওকে, তাহলে আমি অডিও দিয়ে রাখি।
Or PET. With this technique, not only can the anatomical features of the tissues be analyzed, but also their functioning. The PET image provides three-dimensional information on the blood flow and the metabolic processes taking place in the cells of a particular tissue. When a disease develops in an organ, functional disorders appear first. Anatomical changes only present in a later phase. This is why PET is so helpful in diagnosing diseases at an early stage. PET is most commonly used to detect tumors, but it is also used to find neurological abnormalities and measure blood flow in the coronary arteries. PET is usually accompanied by another diagnostic technique called computed tomography, or CT. The images obtained with PET-CT can reveal more anatomical detail, thus increasing the accuracy of the diagnosis. Before performing a PET-CT scan, a small amount of radioactive material, called a radiotracer, is introduced to the patient's body. A detector ring detects the gamma rays emitted during the radioactive decay of the radiotracer. The detector can detect rays coming from any direction within the body. The CT and PET scans are done simultaneously, so there's no need to change the patient's position. Fluorodeoxyglucose, or FDG, is a fluorine isotope attached to this molecule. It is commonly used in PET scans. FDG accumulates in tissues where glucose uptake is increased, in other words, where significant metabolic processes take place. This fluorine isotope has a very short half-life, from 2 to 110 minutes. The disadvantage of this short half-life is that the PET scan must be performed within a short time after the isotope is administered. The advantage is that it represents a smaller radioactive load for the patient. Following intravenous administration of the isotope, the PET-CT scan starts within 50 to 60 minutes. This is the time necessary for the isotope to reach every organ in the body through the circulatory system. After that, the isotope will only be present in tissues where significant metabolic processes take place. Isotope accumulation can be observed in the brain, the heart, the bladder, and the kidneys. If there is cancerous tissue in the body, the PET-CT scan can detect that too, since cell proliferation in tumors requires a high amount of energy and involves an elevated glucose level. As the fluorine isotope decays, it emits positrons. The positrons interact with nearby electrons, producing gamma rays that the PET system can detect. The PET-CT device takes images of the body perpendicular to the longitudinal axis of the body. These slices are then combined to create a 3D image of the entire body. This 3D image enables physicians to identify the exact location of the tumor.
Is that clear? Right. So basically, this is the PET CT scanner হচ্ছে কনসেপ্টটা। এখানে হচ্ছে কি কি থাকতে পারে, তোমাদের এই ম্যাথটা লাগবে, তারপর হচ্ছে মেবি কিছু ব্রেকডাউন কোয়েশ্চেন করতে পারে। সো এই যে ফর দ্যাট পারপাস আমি হচ্ছে আই ক্রিয়েটেড সাম কোয়েশ্চেন্স, কারণ কিছু তো জিজ্ঞেস করে নাই। আচ্ছা, কেন সিটি স্ক্যান লাগে এটা একটু বলে রাখি তোমাদেরকে। এই যে ইফ ইউ জাস্ট ডু পেট স্ক্যান, তাহলে তো কিছু কিছু পার্টস গ্লো করবে, বাট ইউ কান্ট সি দ্য রেস্ট অফ দ্য বডি। মানে এটা কোথায় অ্যাকচুয়ালি হচ্ছে বুঝতে পারতেছ না, বিকজ দ্য পেটস ক্যান অনলি গ্লোজ এট দি প্লেসেস ওয়্যার অ্যাক্টিভিটিস লাইক টেকিং প্লেস, রাইট? আবার সিটিস করলে you can see like the structure of the body more clearly. So দুইটা যখন কম্বাইন করো, তখন you can see the body and the structures যেখানে হচ্ছে অ্যাক্টিভিটি হচ্ছে. So it's like, these show you the hotspot, this show you the entire structure, this shows you the combination out there. বিকজ এই যে ধরো এটা দেখা গেল, রাইট? এখানে এখন হচ্ছে আই থিঙ্ক ডক্টরস ক্যান see this and figure it out, but let's say some of you might be wondering যে like what is what, এটা বোঝা যাচ্ছে না। So তখন যদি একটা সিটি স্ক্যান এটার উপরে প্লেস করা থাকে, তাহলে it's easier for you to see which part of the body are you looking at, right? So these are the ones. আমাদের এটা নিয়ে মেডিকেল ফিজিক্স ডান। আমি হচ্ছে তোমাদেরকে next class আরেকবার বুঝাবো। I'll be starting astrophysics. Astrophysics, I told you, will take me 1.5 class maybe. So আমরা আশা করি তাহলে হচ্ছে by next Saturday we'll be doing question papers. Unit 5 day, paper 5 day start করবো। Paper 5 টা হচ্ছে I will be doing for like couple of weeks. মানে I'll wrap up all the types of planning out there and the graph কেমনে analysis করতে হয়। By mid-February, right? I'll start like, chapter wise. তোমাদেরকে বই দিছে একটা, right? ওই বইগুলো করে করে chapter wise revision start করবো. So that's what we're gonna start from mid-February. So February, March, and first week of April এর মধ্যে I want to wrap everything up. Meanwhile, you'll have your mocks. So mocks এর scheduleটা আমি হচ্ছে Google Classroom এ দিয়ে দিব, like কবে কবে হবে। So but তার আগে I just want to finish paper 5 as well, because paper 5 এর mock নিতে চাই। So yeah, this is your medical physics. A PET scanটা একটু I think it's not very comprehensive in the way that's in your past papers, so আমাদেরকে নিজে থেকে একটু দেখে নিতে হবে। So এটার জন্য যেটা করতে হবে, তোমার বইটা পড়তে হবে। So I'll be going through the textbook because we have to cover everything that's possible. These are some of the questions as I mentioned, but এর বাইরেও কিছু জিজ্ঞেস করতে পারে ওরা। Right, so do you guys have any questions? থাকলে আমাকে বলতে পারো। Right, so we will then do it next class. আমাদের next topic হচ্ছে astrophysics. Astrophysics হচ্ছে super easy and question দেয়, so I think হচ্ছে যে ভালোভাবে যদি তোমাদেরকে দেয়, এটা আমরা বললাম তো it'll take me 1.5 class maybe. So yeah, we'll be continuing with this next class, okay?